Again, I'm Andrew from Scout. So we're going to be talking about Scout's approach to pose estimation and how we performed at a recent pose estimation competition, some lessons learned, prospects, and challenges for the domain, demo of the pose estimation on some synthetic imagery and a trajectory in space, and our future work and kind of challenges for the field as a whole. So a quick intro for Scout. Scout is developing perception systems for spacecraft, so both sensors and compute, to actually solve the vision problem in space. Currently, most space sensors are bespoke, they're compute limited, and they're extremely expensive. And as a result, there's actually relatively few camera systems on orbit that are used for perception. In an era where space is increasingly congested and contested, the sparsity of data that's actually available in space is a huge challenge, so Scout's trying to rise up to meet that need. There are two real domains for that. One of them is close-range proximity operations, so flying up to inspect someone, to refuel them, service them, rendezvous with them, and also a long-range space domain awareness kind of debris tracking problem. So we're going to be really focusing on that first domain here. So vision in the space domain, is it hard or is it just different? People hear space and they kind of think, oh, well, that's going to be incredibly challenging. And it is, but often not in the ways that you would think. Our vision problems actually tend to be relatively straightforward. Our backgrounds are simple. They tend to be either darkness or stars or only the Earth. Our geometries are relatively straightforward because they're all man-made. And our dynamics are relatively straightforward once you get over the orbit stuff. No one ever, a branch doesn't fall in front of my satellite, no one pushes a stroller out in front of it. There are no complicated intersections that were designed before highway engineering that I have to deal with. If I can see and estimate the relative position of an object, I know how it's going to move with respect to me. On the other hand, we're extremely constrained in terms of the hardware we can bring to bear to solve that vision problem. Spacecraft are extremely thermally limited. They're limited in power. Everything needs to be extremely lightweight. And on top of that, there's a real sensitivity to safety and correctness issues. And there's a real reluctance to bring new hardware to the table. As a result, there's a picture on there of a RAD 750, which is the de facto standard RAD hard CPU that's powered everything from Mars rovers to orbiters and all that. That's about equivalent to like a PS1 CPU, so relatively old compute hardware in the domain. And finally, I mentioned already, but we are very sensitive to safety issues. We're here to solve the debris problem, not add to it. As a result, there's extensive verification and validation that needs to go into any of these models on orbit.